This will be for the con exercise, modeling with sinusoidal functions, phase shift. So you need to be familiar with these four trig functions. The first one is y equals sine of x. The second one is y equals cosine of x, y equals negative sine of x, and y equals negative cosine of x. So we're going to be using one of these four functions as the basis for our equation. Okay, the daily low temperature in, can't pronounce it, Guangzhou, China, varies over time in a periodic way that can be modeled by a trig function. The period is exactly 1 year. The temp peaks around July 26th at 78 Fahrenheit. Okay, since it's a peak, this is going to be the maximum. And its minimum half a year later at 49 Fahrenheit. Assuming a year is 365 days, July 26th is 206 over 365 of a year after January 1st. Find the formula that models the low temperature T years after January 1st. Define the function using radians. Okay, so you want to remember that T is in years when we create our function, and the function is going to be in terms of T as well. All right, so let's do a rough sketch here. And the x-axis is T, probably going to be T for all of these problems. Okay, it peaks around July 26th at 78 Fahrenheit. So the maximum is going to be at 78. All right, and it said July 26th is 206 over 365 of a year after January 1st. All right, so here is January 1st, and T is in years. So this maximum is at 206 over 365. And then the minimum is half a year later at 49. All right, so it goes down to the minimum, and then it comes back up. This point here, the minimum is 49. All right, so let's see. We said in the beginning, the period is exactly 1 year. All right, we'll do the period in a minute. Right here, out of the four graphs, this is clearly a positive cosine. All right, so I'm going to start with the cosine. And the amplitude is halfway between these two numbers. All right, it's going to be halfway down. So if we do 78 minus 49, okay, the value for A is going to be 78 minus 49 divided by 2. And I get 14.5. Okay, so that number goes in the front. And let's see. If you don't remember the equation, I'll write the equation here. We are using A times cosine of A times cosine of B, and X plus C plus D. Okay, in this section, I tested it out. In this section, you can leave it in factored form. So the amplitude goes in front of the trig function, cosine or sine. Now, the value for B is based on the period. They said the period is 1 year. Okay, so the period is just 1, and the formula for period equals 2 pi over B. So cross multiply, B times 1 equals 2 pi. All right, so B is just 2 pi. So the B is the number that's multiplied by X, but we're going to leave it in factored form because we need to find the phase shift, okay? And as you can see, this function starts here. It's actually shifted to the right by 206 over 365 units. So to shift it to the right by this much, we need to subtract that from x. But again, we're not using x, we're using t. So instead of x, it's going to be a t minus 206 over 365. Finally, the midline part is easy. That is the horizontal line that cuts the trig function in half, exactly between 78 and 49. Okay, so just find the average. 78 plus 49 divided by 2, and I get 63.5. So that is just added to the end of this function, 63.5. All right, so this is our answer right here. And if I can pull up the box here. All right, I'm going to have to erase some of this stuff. All right, so in the box we have 14.5 cosine, parentheses, 2 pi, parentheses, t minus 206 slash 365, and go outside parentheses, plus 63.5. So that's it. All right, a pendulum is swinging back and forth after t seconds. The horizontal distance from the bob to the place where it was released is given by this function. How often does the bob cross its midline? Give an exact answer. All right. So you don't really have to sketch. You don't have to sketch an exact graph of this. All right. The pendulum is swinging back and forth, and it's a cosine function. Just like the sine function, it's basically just going to go up and down, right? So, if you measure the period from, let's say, minimum to minimum, that's the period, right? Within that period, it's going to cross the midline twice. Once, twice. Okay? So every time the period goes by, it crosses the midline twice. So basically, if we find the period and divide by 2, we can find how often the bob crosses the midline. So from this function here, we just have to find the period. All right? So the function is in the form of a times cosine of b times t minus c plus d. All right, this function is in this form. The only thing is they put the d in the front. It doesn't matter, though, because we're just looking for the period, which is based on the number b. All right. Now, notice once you factor this, b is just a number that's multiplied by t. So if we just find that here, we can easily find the period. Now, if you're adding or subtracting over a common denominator, each term is over that denominator. So if I distributed just this mess right here, I would have 2 pi t over 20. And I would have 2 pi times negative 2 over 20. 2 pi times negative 2 is negative 4 pi. And that's over 20. We are just looking for the value of b, so we don't even need this right here. All right, so b is what's multiplied by t, and in this function here, we can clearly see it is 2 pi over 20 that's multiplied by t. So that's the value of b. b is 2 pi over 20. Okay, and the formula for period is 2 pi over b. So that's going to be 2 pi, and the value for b is 2 pi over 20. All right, keep, change, flip. So instead of dividing by 2 pi over 20, I'm going to multiply by 20 over 2 pi. The 2 pi's cancel, and the period is just 20. Now, it hits it twice within the period, so we just want to take half of 20. And that's just 10. Okay? The full period, or the full cycle, is 20, but it hits the midline every 10 seconds. So you just enter the 10 in the box. In the month of March, the temp at the South Pole varies over the day in a periodic way that can be modeled by the trig function. Highest temperature, -50, reached at 2 p.m. Lowest temperature, -54, and is reached half a day apart from the highest at 2 a.m. Find the formula of the trig function that models the temperature in March T hours after midnight. Okay, T is in hours, and you start at midnight. And define the function in radians. All right, and then there's a follow-up question. We'll do that later. All right, we'll do a rough sketch as always. And of course, the x-axis is in terms of T. All right, so we want to do T hours after midnight. So 2 a.m. is going to be 2 hours after midnight. All right, so right here, this is going to be a 2 because T is in terms of hours. 2 a.m. is 2 hours after midnight, and that's the minimum at -54. So maybe I'll put the 2 on the top instead so I can draw the graph below the axis. All right, this is 2 hours after midnight. The minimum is -54. So this right here is at -54. All right, and then 2 p.m. is 12 hours later. So I'm going to add 12 hours to the number 2. So that's going to be at 14. And it hits -50. It reaches the high. All right. So it basically starts here, goes up to 14, and then it's going to come back down. All right. So I drew this a little flat, but this is clearly a negative cosine function. All right, that's a negative cosine. Now for the amplitude in the front, it's halfway between the minimum and the maximum. So clearly 54 minus 50 is 4 units. Divided by 2, that's just going to be a 2. All right. And the period is a full day. How do I know that? Because the highest temp and the lowest temp is a half a day apart. A half a day is 12 hours. So that means a full day is 24 hours. All right, because it goes from highest to lowest. Highest to lowest is only half the period. All right, the full period is going to be 24 hours. So we need to find the value of B based on the period. All right, the formula for period equals 2 pi over B, and that is 24. Cross multiply, 24b equals 2 pi divided by 24. B is going to be 2 pi over 24. You can reduce this if you want. They actually don't make you reduce it, but if you like, you can make it pi over 12. Okay, so that's going to be pi over 12. We have the t here, and we need to do the phase shift inside the parentheses. So clearly, if you look at this graph, the negative cosine starts at +2. So the graph actually shifted to the right 2 units. In order to shift the graph to the right 2 units, you have to subtract 2 units from t. So that's going to be a t minus 2. Finally, the midline, the easiest part, it's exactly between -50 and -54. So right in between these two is going to be a -52. All right. So that's our equation. All right, so click in the box. I'm going to do -2 cosine. I actually should have put parentheses on this. Put it here and here. Okay, so that's better. -2 cosine, parentheses, pi over 12, so pi/12. Hit the right arrow key, parentheses again, t minus 2. And then outside the parentheses, -52. Okay, so we have our equation. Now, follow up. What is the temperature at 5 p.m. round to 2 decimal places? Okay, 5 p.m. is actually, we started at 12 a.m., midnight. Then if you go to 12 p.m., that's 12 hours. And then if you go to 5 p.m., that's an additional 5 hours. So 5 p.m. is actually 17 hours after midnight. Okay, 17 hours after midnight is 5 p.m. So in order to find the temperature at 5 p.m., you need to plug in 17 in this equation. All right. Now, it's a big equation, but you're going to use the calculator. The only thing is you have to make sure it is set to radians. Okay. So I'll show you on the Google calculator. Actually, I'll show you on this one here. All right. Just make sure it's set to radians. RAD is in boldface. Okay. -2 cosine. So I'm going to do -2 cosine, parentheses. Okay, it made parentheses already. Pi over 12. So pi divided by 12. Parentheses again. T minus 2, so it's going to be 17 minus 2. Or you can just put 15. Okay, close parentheses twice. And then minus 52 at the end. All right. Hit equals. And, okay, this calculator can't do that. All right, I suggest you use your own calculator, but we're going to do -2 cosine pi over 12. Let's see. Pi divided by 12, parentheses again, t minus 2, so it's going to be 17 minus 2. Close parentheses, minus 52. Okay, and make sure radians is bold-faced or highlighted. So -2 cosine pi over 12, t minus 2 minus 52. All right, big number here, but that's okay. We're going to round off to 2 decimals. Look at the third number. If it's 5 or more, you round it up. So -50.58 is going to be -50.59. So right in the box, -50.59. Now, does this answer make sense? Well, the temp goes from -50 to -54, so I think it definitely makes sense. And there you go. All right, one more. I had to look for this one. The average daily temp in Celsius in Karachi, Pakistan on the 10th day of the year is modeled by this function. What are the highest and lowest daily highs in Karachi? All right, so we're looking for the highest and lowest. And what you want to do, since this is a cosine graph, if you just take your basic cosine function All right, it starts here, and it goes down, and it comes back up. The maximum is at 1, and the minimum is at -1. You can also see this on the unit circle, okay? So for this cosine function right here, the cosine of whatever, for this part in brackets, the maximum is going to be 1, and the minimum is -1. That's for a cosine function. So all you have to do is do 29 minus 5 times 1 and 29 minus 5 times -1. Okay, the highest or lowest this is going to be positive or -1. So if you do 29 minus 5 times 1, you're going to get 24. If you do 29 minus 5 times -1, you're going to get 34. So that's it. The highest is 34, and the lowest is 24. So that one's one of the easier ones. And the same is true for the sine function. Okay, if this were a sine function, it would just be like this. And the maximum would be at 1, the minimum would be at -1. So you would still do the same thing if this were a sine function.